last bit that we need to talk about here about the periodic table has to do with trends or patterns that we actually can see on the periodic table. Okay, so as we can see, the elements are grouped according to their physical and chemical properties, and what we will see after we talk about electron configurations is their electron configurations also create a pattern as well. This creates that periodic repetition on the table and allows us to see the patterns in their properties or their trends. So we are going to look at two specific trends on the table. We're going to look at the trend in atomic radius, and we're going to look at the trend in something called ionization energy. I'm going to explain exactly what these are, and we're also going to talk about the trends that exist on the table and why they are there. Okay, so each of these show a trend as you move across a period and down a group. And just so you understand, when we talk about across a period, we're talking about moving from left to right on the table, and down the group I think is pretty self-explanatory. It's from the top to the bottom of the table. So the first one is atomic radius. Atomic radius is defined as half of the distance between the nuclei of adjacent atoms. So if you think about an atom, we have the nucleus here with the rings of electrons. Okay, we know that the diameter of this should be from the nucleus here to this outside portion. But instead what we do, if we have another atom of the same type next to it, now I'm only going to draw the outside ring, okay, what we do is we measure this distance here and divide it by 2. And if you think about it, these electrons that are going around the outside, they are moving, and they're moving very fast. So this outer boundary is really hard to determine, whereas the nucleus is not moving. If you take the distance between the two nuclei and actually shifted it over, it would be the diameter of the atom itself. So by taking the distance here and dividing it by 2, we actually get the radius. And we do that because we can actually measure that distance since the nuclei are not moving. Now, this decreases as atomic number increases due to the greater nuclear charge. So this is as we go across a period, it decreases. And the greater nuclear charge means that I have more protons. Because the number of protons increases, those protons actually pull those electrons in closer. The electrons aren't any further away. We are adding them on to the exact same energy level or exact same ring around the nucleus. So greater pull means they pull them in tighter. So that is across a group. Down a period, we see a dramatic increase. So as we go down the group, this is going to increase the atomic radius, and this is because we add energy levels. In other words, we add a ring. So we have nucleus with 1 ring versus nucleus with 2 rings. Okay, it's going to increase, and then as we go to the third one, it's 3 rings, and so on. So that's atomic radius. The second characteristic is ionization energy. Ionization energy is the amount of energy required to pull an electron away from an atom. And this is going to form a positively charged ion. All right, the ionization energy increases with increasing atomic number, again, as we move across a period. And it does this, so it's an opposite trend. As we went across a period before with atomic radius, it decreased. In this case, ionization energy increases, but it's because of the same reason, because of more protons. Now, let's look at the trend down a group. We actually get a dramatic decrease in energies at the same interval. So as we go down a group, it's going to decrease, okay? And that's because the electrons are further away. The further away, the less pull you get, and so the easier it is to take that away. Now, we are going to be looking at these two trends in a lab that we are going to be doing that I will explain to you in the next video.